Hello everyone, it's Left Playing here again. And I'm back with yet another video about this beautiful aircraft, the Dash 8. Today I want to talk to you about how the different systems work and also build them outside just to show you how they work, because as you see it's a big messy spider web, and it's really hard for me to explain what's going on here if you can't actually see the blocks, and is also uh, spaced tightly together. Is really hard for me. So what I'm gonna do is I'm gonna go over the different systems that I built here and then build them again outside, I guess one by one. Just so you guys understand what I did there, and either use the same technique in your airplanes or come up with a better one and tell me, okay, Left Playing, your system is way too complicated and there's a much easier way to do it. So any comments are welcome. I'm eager to learn. Right. So, yeah, let's just start front to back. What do we have here? First of all, of course, here we have the cockpit and the main cockpit seat, which is connected to everything. This, at the moment, is the only place where you can fly this plane from. I'm planning to have a seat in the back in the future, so you can have an outside view, overview. That's probably going to be a little bit easier to fly because, yeah, if you're in the cockpit seat, you're very limited in what you can see, especially if you have a nose-up attitude. It's really hard to see where you are, especially the fence, the boundary of the map. Is hard to see, so yeah. I crashed into the wall a few times because I didn't realize where I was. And as for the outside view, of course, this big plane is in the way. You can work around it, but it's really stressful to find a good spot. No, so in the future we're gonna have the choice to fly this plane in the cockpit view from the flight deck or in the outside view. Right. Let's go back in and let's see what the systems are. So first of all, here we have the button layout of the driver's seat. Is incomplete because of course we have the parking brake, the gear lever and the master switch already here in the cockpit, so we don't need them in this layout. And the way this is done is not like on the number pad where it starts at the bottom. No, it starts at the top left, 1, 2, 3, 4, 5. Then we have button, the switch number 6, which is the gear. 7, 8. The parking brake switch is number 9, and number 0 is the master switch. And in case you didn't know, if you connect the driver's seat to the math block with the AND or WS or AND function, it takes up a spot. Like it takes up a spot on your for your buttons. But if you connect all the buttons and switches first, you can still use 10 of them, and additionally add those converters. They are still, it says it's number 10, both of them. Doesn't matter, this switch still works. So, yeah, because I heard in other videos sometimes that people say, okay, these blocks take a space, so you have 2 less buttons or switches to work with. No, it actually works. I kind of found it out by coincidence. Right, so these are all the buttons and the switches, and they are going to this unit, which is, its only purpose is to allow a second or third driver seat, which for some reason when I tested it didn't work, so I have to do some bug fixing, but this is where it's all gonna come together in the future. Um, so all the buttons and switches are connected to the respective gates, and they are of course OR gates if there is a button. So you can press the button on either seat, and in the case of a switch, of course, we have the XOR gate, the exclusive OR gate, that will change its state whenever the switch is pressed. No matter which seat you are on, if you're in the cockpit seat, activate the parking brake, then it's going to be active here. But if you're going to go to the back seat and activate the switch there, of course, it's not they're both going to be on, and therefore this gate, because it's an exclusive OR, will turn off. The only thing is that, of course, now here you can see the parking brake is on when it really isn't, but that's just a minor inconvenience, I'd say. So, yeah, and from here on, all the control inputs are distributed to the respective systems. Right. So I think for today that the video is not gonna get too long and boring. I'm gonna start with one single system, and this is this system here. It's just this system. All the stuff that's around it is just, you know, a timer, so the engine start in sequence. The core is just this thing here, and this white counter is what in the end gives us our desired power output. So it's this indication. It's your power input to the engine with this counter. So this unit is central. It's the same unit for both of the engines. And then it splits, goes into the engines where the next systems are, and these are individual for each engine because they start up in sequence and they have their own their own system. They're not controlled via a single unit because, of course, they're individual engines, so yeah, they work on their own. Right. So I guess the first thing we're gonna do is we're gonna build a, how can I call it? We're gonna build a coupled counter system, meaning that, let me just start this up for a second. Meaning that we have a range from 0 to 100% in our power setting here. But as I said before, of course, these big jet and turboprop engines with a jet engine inside and a big propeller in the front, they take some time to really produce the power that is set by the pilot. So we have to add a delay, or else we're just counting up and down on the counter, and the power is there right away. So again, this counter is our desired engine power setting. It's not the actual engine power setting. For that, we have to couple this desired setting to the actual counter in the engine. Right. So let's build ourselves a little table here. Like this. Okay. And actually, let's give us a little bit. That's better. Alright. So, of course, first of all, we need to have a counter block. Now, in order to limit this counter, we have to limit this counter, of course. So we only have two buttons to increase and decrease the thrust. And we don't want to go into negatives with this counter. Also, we don't want to go over a certain value. In this case, 100 or 100%. And I think in general it's always a good idea to work, if you work with counters, to work with a range from 0 to 100. Um, just because it's easy, it's always the same build. Um, I think it's a good, a good speed, a good time that it takes for the whole range. It takes 2.5 seconds at a normal 40 tick per second rate to go from 0 to 100, and you can always, of course, afterwards take the signal and convert it. In the case of the engines, the maximum power output of the engines is, I think, 2000 units. So, of course, all we have to do is take the maximum number here. No, take the 2000, the desired maximum output, 2000 divided by 100, because that's the maximum power output. That's the maximum output of this counter, and multiply it. Right. So 2000 divided by 100 is 20. So if we want to use this signal here, we have to use a multiplier block, and you can use a counter. I always use the memory bits. Store the value of 20 in there. This counter times 20 gives you the output signal with the desired range of 0 to 2000. And just on a side note, the reason I always use these memory blocks, these little memory units, instead of the counter blocks, there are two reasons for this. First of all, you can always reset the counter by pressing E on it. That's dangerous if you have stored a certain value that you need, and you reset it, maybe you don't even realize it, and then your whole system won't work. This, on the other hand, you cannot reset. At least not by pressing E on it. You have to connect the tick button, either make it white to erase the single channel, or black to erase the whole thing. But it has to happen deliberately. Right. Also, why I use the mem blocks is because if you have a system that's hidden inside the plane, like this, for example, I can always distinguish these normal math blocks from the counter blocks, from the memory blocks. And I know if there is a memory block, it's a certain value that I need. And the counter blocks are always dynamic. These counter blocks never store a static value that never changes. Counter blocks are gonna count, and memory blocks are gonna memory block. Yeah. Right, but back to this. So first of all, of course, we need two buttons. This. Two buttons, one for increase, one for decrease. But we cannot connect them directly because, of course, then we can go into the negatives, then we can go above 100, basically without limit. So we don't want that. So to limit this counter, all we have to do is place, that's not pretty. Place two more math blocks and set them to less than and greater than. Right. For this, because we're going to compare the value of the counter to another value, this counter has to be white. It's going to be this part. Then we have to add two static values that are going to be compared with the counter value, and they are going to be black. Cool. So what's nice is the first value we need is 0, and 0 is already stored. Actually, we need it on this side, because we have to make sure that the counter is greater than 0. If the counter is greater than 0, we can we can lower the number. We can subtract. and if the counter, only if the counter is less than 100, so here we're gonna store 100, only if the counter is less than 100, we can add to it. Right. Now, to store values in this memory bit, I've made a unit that's called oh, it's such a mess in my inventory. The counter reader is, yeah, if you have a lot of stuff to program, this is really handy for you. You can weld it to your creation and just connect this counter and the button to the memory bit you want to program and to the number and program it. Yeah, if you just have one or two counters, it's a bit much to spawn this in. We can just, create the value on the fly with a counter and a tick button, and then just store it. Right, so we need 100, it's the third color. That's 100 now. And now we can, on this side, right? Less than 100. Right, so connect the button, connect the number input, and that should be 100 now. And we can always check that. Make a number block, connect it. Of course now it shows 0, but for value for the hundreds we have a value of 1. So it's 1, probably 0, 0, 100. So right, so let's connect this up. I'm gonna connect the counter to the greater or less than checks and the number counterpart. So as you see, at the moment the counter is less than 100, of course it's 0, but is not greater than 0, it's equal to 0. So at the moment we could not decrease the counter value, but we can always increase it. Right. Now, and because we cannot connect this back, we have to add another math block, and this time it's gonna be a multiply block. And this is what's actually gonna be connected to the switches and then back to the counter. Now all we have to do is tell the counter block that the input coming from this multiplier block is not going to be 1 if it's active, it's going to be -1. And that's working like with all the stuff in the mod pack with color coding. So instead of using a value of 1, we give it a value of -1. That should work now. Right. And I think we're gonna grab a C just for the convenience of it. Let's have a seed here. And connect these two buttons, plus and minus, and let's also have a number display for the counter value. Is this facing the right way? Yeah, I think so. And I guess I'm gonna get rid of this airplane because it's very laggy. I just realized. Oh, that's better. Right, so if I done everything correctly, we should be able to count up. Oh, of course, yeah, I should connect the number output to the actual number display, otherwise we cannot see. Shit. Cool, so, is it working? Counting up to 102, alright. Counting down to -2. sometimes it works, sometimes it doesn't. I don't really know. I think in the airplane I used the same values, but it worked. But yeah, doesn't matter. We can always change these values. So if we count 2 too much, we should be able to go around. I mean, you can also say that's fine. Okay, we don't -2. It doesn't really matter if you have -2 or 0 if you're talking about engine power, because engine power, negative engine power, is not going to move the engine. And if you got 100 or 102%, also doesn't matter. But if you want to be pedantic about it, well, we can always change these values here in the memory box. So first I would take a number 2, right? So 1, 2. Give it this value. And instead of 100, we're gonna set 98. Right, so now I did it the wrong way. Nice, nice, really nice. Okay, we need to be less than 98. And yeah, I can just cross-wire it. Screw it. So this has to go here and this has to go here. Oh my god, that's embarrassing. 100 we cannot increase. And down to 0 and we cannot decrease. Cool. So that's working. Now we have to couple this, and I'm actually going to move the number display. Up here. Now we're going to couple this to another counter to add the delay. So what we're gonna do is we add this counter here, and in order for it to count, we need the difference. Set this to minus. We need the difference between the setting, the desired setting, and the actual setting. Okay, so that means if we have, let's say 0 here and 0 there, it's the same value. We have 10 here and 10 there. The difference is 0, so is the input. If there's 0 difference, we need 0 change to the counter. If there's a positive difference, if this value is greater than this one, if we have 20 here and 10 here, well, the difference is 10. So positive 10, that's going to be added here. And we're not going to take this exact value, we're going to scale it down a bit, because of course if we have if we add this difference, the actual difference to the counter, well, the difference is going to be 0. We have a delay of 1 tick. Or maybe you're going to overshoot because of the delay within the circuit. We don't want that. So what we're also going to add is a multiplier block. My space management is not very good today. We're going to add a multiplier block and the memory block for the scale. Right, let's connect this up, what we have until now. Want to take this value, the desired value, and the actual counter value. We're going to subtract them from each other. multiply them with a certain value, and then feed it back to the counter. Easy. Now, you can pretty much take any number here, smaller than 1, between 0 and 1. The smaller the number, the bigger your delay is gonna be. Yeah, let's just test out different numbers. Let's add the old tick button, the old counter, and let's give it a value of 0.1 for now. Right. And let's also add a display for this counter. So both counters are 0, and this circuit should be working now. But you see, it's very fast. It doesn't lag very far behind. It's pretty much instant at 0.1. And what you also see, well, you see it more clearly when we go, let's go a little bit lower. This time, let's go 0.01. Wait. We will never actually reach this the desired value with this counter, in theory, because what we do, we take the difference and take 1/10 or 1/100th of the difference and add it, and there's always going to be a rest difference. We can never reach this value. But yeah, it's close enough. If we have thousands or 0.0001 below or above this desired value, it won't make a difference. So yeah, that's cool. So this should be now 0.01. Let's see what happens. And you see it's already way slower than before. Still doesn't take too long. 5-6 seconds. And now we got 25. And of course, the further you are, the bigger the difference, the faster this counter will count. And then it will slowly come closer and closer to the desired value, until we are up at the point that, yeah, we can say it's 100. Cool. So this is a really small, compact system. So you don't, of course, you don't need these number displays. You don't need this. So it's just 4, 4, and 7. It's 11 blocks, right? It's 11 blocks plus the 2 buttons for an engine system that behaves like a jet engine system because it's lagging behind. Right, and I mean, what I said before, the last step would just be add a math block, set it to multiply, give it a value, let's get up the smart raster. Let's take the value 20. So we have a thruster that will go from 0 to 2000 units of power. I mean, of course, you can see the actual power level right now because we're standing still on the ground, and we're welded to the ground, obviously. And of course, as this will never reach true zero, in theory, this engine, this thruster, will never turn off. So to prevent that, to have a, to be able to park your plane and turn it off, you can just connect a switch to this multiplier gate and be able to turn the thruster on and off. Of course, now it's running and supplying an engine sound, but the power, I guess, is so low that it doesn't actually, it can't actually move anything here. So let's actually see how much do we need to move us. Beautiful. Yeah, and that's basically how you create a jet engine system. Cool. And I think that's it for this video. I think we're already way over the time. And yeah, next time I guess we're gonna have a look at the propeller system, at the rest of the engine system, and then we're gonna move on to all the other systems, like the gear system, the flap system, that also use the new number logic and the smart engines instead of the thrusters. Right. But until then, thank you for watching. Please rate and comment. If you have any questions, just hit me up in the comments, add me on Steam. I'm also in the Discord, in Scrapman's and Khan's Discord, and the Scrap Mechanic Discord. So, yeah, I'm basically everywhere. I'm on Reddit. If you got anything to say, if you have any questions, anything I can do better, yeah, don't hesitate, just contact me. I'm happy for every input I can get. Right, thanks very much, and I'll see you in the next video.